5 numeric value questions were asked from the section Matrices and Determinants in the recently conducted January 2024 session of Joint Entrance Examination Main Mathematics. These examinations were conducted from 27th January 2024 to 1st February 2024. We will now discuss those 5 numeric value questions from the section Matrices and Determinants. Let's now take up the first question that has appeared in the JEE Main Examination held on 27th January 2024 in the first shift. Let A be a matrix whose first row is 2, 0, 1, second row 1, 1, 0, third row 1, 0, 1, and capital B is equal to B1, B2, B3, where B1, B2, B3 are column matrices and A multiplied by B1 is equal to the column matrix 1, 0, 0, A, B2 is equal to 2, 3, 0, A, B3 is equal to 3, 2, 1. If alpha is equal to determinant of B and beta is the sum of all the diagonal elements of B, then alpha cube plus beta cube is equal to. Right. We are given a 3 by 3 matrix capital A and capital B is given as it's a 3 by 3 matrix whose first column is B1, second column B2, third column B3, and this B1, B2, B3 are given in such a manner AB1 is equal to 1, 0, 0, AB2 is 2, 3, 0, AB3 is 3, 2, 1, and if alpha is the determinant of such a matrix B and beta is the sum of the diagonal elements of B, that means to say beta is the trace of capital B, then required to find the value of alpha cube plus beta cube. Let's now discuss the solution of the problem in detail. Given this matrix capital A, which is a 3 by 3 matrix, and capital B is also a 3 by 3 matrix whose columns are given. The first column is B1, B2, second column is B2, third column is B3. Let us say B1 is the column matrix A, B, C consisting of the elements A, B, C. B2 column matrix P, Q, R, B3 X, Y, Z. We are given AB1 is 1, 0, 0, AB2 is 2, 3, 0, AB3 is 3, 2, 1. We continue in the next slide. Right. So we deal with the 3 cases what we have written in the last slide. First case is AB1 is equal to 1, 0, 0, where A is that 2 by 2 matrix and B1 is A, the matrix, column matrix ABC. Second case and the third case. So 3 cases we deal with. First we go to the first case. So this will imply A means this 3 by 3 matrix, B1 means column vector ABC, 1, 0, 0 is given. Now multiply. So if you multiply this 3 by 3 matrix with this column matrix ABC, you will get 2A plus C. That is the first element you will get. This is 3 by 3 multiplied by 3 by 1. You will get 3 by 1. That is again a column vector. This is what is given. So it is 2A plus C is 1. This is the one. A plus B is 0. Next one. A plus C is 0, the next one. It's very easy. A is equal to minus C, A is equal to minus B, and 2A plus C is equal to 1. Solving, we get A is equal to 1, B is equal to minus 1, C is equal to minus 1. Therefore, the column vector B1 is 1, A, B, C, 1, minus 1, minus 1. So in a similar way, the second case also, we take the matrix capital A, B2 is PQR, and it is given 2, 3, 0. Now when you multiply 2P plus R, 2P plus R is 2, P plus Q is 3, P plus R is 0. So again, solving these three equations, you'll get P is equal to 2, Q is equal to 1, R is equal to minus 2. Then B2 will be the column matrix 2, 1, minus 2. So in this case also, we do the same thing, right? And B3 is X, Y, Z, we have written, and write the three equations. And we solve, we get X is equal to 2, Y is equal to 0, Z is equal to minus 1. Then B3 will be the column vector X, Y, Z, that is 2, 0, minus 1. Thus, the column vectors of capital B we have obtained. Therefore, we can write down the matrix capital B. Right. We write down capital B. What is capital B? Capital B is, the first column is B1, that is 1, minus 1, minus 1. B, second column is B2, 2, 1, minus 2. B3, the third column, that will be 2, 0, minus 1. Now it is very easy now. So what is to be found out? One is the trace and the other is the determinant. Now given beta is the sum of all the diagonal elements of B. That means the trace of B. The trace is sum of all the diagonal elements, means 1 plus 1 minus 1. That is 1. And alpha is the determinant of B. Write the determinant of this matrix and expand through its first row and simplify. You will get minus 1 plus minus 2 plus 6, that is equal to 3. Thus, we got alpha is 3, beta is 1, and required to find the value of alpha cube plus beta cube, that is 3 cube plus 1 cube, that is equal to 28. So the answer to this question is 28, and that is the detailed discussion of the solution of the given problem. I am sure that you have understood the solution of this problem. We move on to the next question, that is question number 2. And this question has appeared in the JEE Main Examination held on 27 January 2024 in the second shift. The given question is, let A be a 2 by 2 real matrix and I be the identity matrix of order 2. If the roots of the equation determinant of A minus xi is equal to 0, be minus 1 and 3, then the sum of the diagonal elements of the matrix capital A square is, capital A is given to be a 2 by 2 real matrix and capital I is the 2 by 2 identity matrix, and it is given the roots of this equation determinant of A minus xi is equal to 0 are given to be minus 1 and 3, then required to find the sum of the diagonal elements of the matrix A square. And if you know the concept of eigenvalues of a matrix, of a square matrix, and the properties of the eigenvalues, then this question is very, very easy. Now, minus 1 and 3 are the roots of this equation, means they are the eigenvalues of A. The eigenvalues of A is minus 1 and 3. And the properties, if you recall, if lambda is an eigenvalue of A, then lambda square is also an eigenvalue of A square. Then here you got to two eigenvalues, minus 1 and 3. Therefore, the eigenvalues of A square will be minus 1 square and 3 square. And we want the sum of the diagonal elements of A square, then it will be minus 1 square plus 3 square, that is equal to 1 plus 3, that is equal to 10. 10 is your answer. And if you know these concepts, it's very easy. Now, our intention in this is, not many colleges and not many teachers teach the eigenvalues and eigenvalues and the concepts, the properties of eigenvalues. They don't teach because it is not included in the syllabus. But in some colleges they do teach. But anyway, here my effort now is that we do not talk about eigenvalues, eigenvectors. Without that, we will try to solve this problem, right? So we are given a 2 by 2 matrix A, B, C, D, where A, B, C, D are real numbers. And determinant of A minus xi is equal to 0. Determinant of, from the matrix A, B, C, D, subtract x from the diagonal entries. That is A minus x, D minus x, determinant is equal to 0. Expand it, A minus x into D minus x, minus BC is equal to 0. Now multiply, and this will be x square minus A plus D into x plus AD minus BC. And if you observe this, A plus D is the trace of the matrix A, and AD minus BC is the determinant of A. Right. Now, for this determinant of A minus xi is equal to 0, minus 1 and 3 are the roots. That means the roots of this is minus 1 and 3 means the roots of this equation are minus 1 and 3. So for this being a quadratic equation, we write down sum of the roots. Sum of the roots will be minus the coefficient of x by the coefficient of x square. And the sum of the roots is A plus D. And the sum of the roots are minus 1 and 3. Minus 1 plus 3, that is 2. Therefore, A plus D is equal to 2. And the product of the roots is AD minus BC, the constant term, divided by the coefficient of x square, that is AD minus BC only. But the product of the roots is minus 1 and 3, that is minus 3. That is AD minus BC is equal to minus 3. Agreed. So what is that we want? We want the sum of the diagonal elements of A square. So we have A and we write down A square. So A square is ABCD multiplied by ABCD, you write, and you will get this matrix. Agreed. A square plus BC, AB plus BD, that is the first row. Second row is AC plus CD and BC plus D square. Now write down the sum of the diagonal elements of A square. They will be A square plus BC plus BC plus D square. Take this A square plus D square and write it as a perfect square and adjust the terms. We write A plus D whole square, perfect square, adjusted minus 2AD, adjusted, and this BC plus BC is 2BC. Now this is A plus D whole square, A plus D is 2, so we write 2 square. This is minus 2 into AD minus BC, and this is 4 minus 2 into AD minus BC is given to be minus 3. So 4 minus 2 into minus 3, that will be 10. So the sum of the diagonal elements of A square is 10. So the answer to this question is 10, and that is the detailed discussion of the solution of the given problem. And I am sure that you have understood the solution of this problem. And let's move to the next question, question number 3. And this question has appeared in the JEE Main Examination held on 29th January 2024 in the second shift. The given question is, let for any 3 distinct consecutive terms A, B, C of an arithmetic progression, the lines AX plus BY plus C is equal to 0 be concurrent at the point P, and Q alpha comma beta be a point such that the system of equations x plus y plus z is equal to 6, 2x plus 5y plus alpha z is equal to beta, and x plus 2y plus 3z is equal to 4 has infinitely many solutions, then PQ square, the distance between P and Q and its square, is equal to. So it is given for any 3 consecutive terms A, B, C of an AP, we get a system of equations AX plus BY plus C, and it is given they are concurrent at the point P. So find out the coordinates of that point P. Agreed. And it is given a system involving alpha and beta, system of 3 equations in 3 unknowns, and alpha beta are there in those equations, and q alpha beta, that means the alpha beta are taken in such a manner that this system of equations has infinitely many solutions. Then you know what is q alpha beta and the coordinates of P, and find out the distance between P to Q and its square. So that's the question. Let's move to the solution. Let's now discuss the solution of the problem in detail. First, we are given A, B, C or any 3 distinct consecutive terms of an AP. So you take a triad A, B, C, which are the consecutive terms of an AP, and write down the corresponding equation ax plus by plus c is equal to 0. And how many triads A, B, C that you can have such that they are the consecutive terms of an AP? We have infinitely many triads like this. So for each triad we have this equation. Therefore, we have infinitely many triads and we have infinitely many equations. And that's how you will get a system of linear equations. And what are the properties of A, B, C? The A, B, C are given to be the consecutive terms of an arithmetic progression. Therefore, 2b is equal to 2 times the median is 2 times the arithmetic mean, that is 2b is equal to a plus c, and now write down a minus 2b plus c is equal to 0, and look at the equation ax plus by plus c is equal to 0. Look at this one, a minus 2b plus c is equal to 0. This tells you x is equal to 1 and y is equal to minus 2. If you substitute in this, then this equation is satisfied because of this. So this tells you all these equations, when solved, you will get a single point that x is equal to 1 and b is equal to x is equal to 1 and y is equal to minus 2. So x is equal to 1 and y is equal to minus 2 is a solution of this given system of equations. So, and this is P, that is capital P. Therefore, the system of equations is concurrent at the point P whose coordinates are 1, minus 2. Right, that is the coordinates of P, thus we have found. So let's move to the second. We are given Q with coordinates alpha, beta is a point such that the system of these equations, 3 equations, 3 unknowns involving alpha and beta, has infinitely many solutions. So we ask the question, for what values of alpha, beta, this system of equations has infinitely many solutions? That we do it in the next slide. So we have asked this question, and for this we will use the determinant methods for this. So to have infinitely many solutions for this system of equations, we will use the determinant methods. Right. To get into the determinant methods, we first of all write down the matrix form of the given system of equations. Ax is equal to b, where A is the coefficient matrix, that is 1, 1, 1, and 2, 5 alpha, 1, 2, 3, and the given values are 6, beta, 4, and the column vector consisting of the variables are x, y, z. Ax is equal to b will give you this system of equations. Right. And we recall a result if delta is equal to, what is delta? Delta is the determinant of A, is equal to delta 1 is equal to delta 2 is equal to delta 3 is equal to 0, then this given system has infinitely many solutions. And what is delta 1? Delta 1 is same as delta with the first column is replaced by B, that is 6 beta 4. Similarly for delta 2 and delta 3. Let's first of all take delta. Delta is equal to 0. That is determinant of A. That is 1, 1, 1, 2, 5 alpha, 1, 2, 3. Determinant is equal to 0. Expand by its first row. Agreed. And simplify. We'll get alpha is equal to 8. Right. So we got the value of alpha. Right. Look at this delta. Look at this delta. What will be convenient for you to get the value of beta? That is, if I replace 1 alpha 3 by B, that is 6 beta 4, that means delta 3 if you consider, then if you expand it, you will get the value of beta. Right. So delta 3 we take, and delta 3 is same as the delta with the third column is replaced by 6 beta 4, which is written in red. Expand, that is equal to 0. Expand by its first row. Simplify. You will get beta is equal to 6. Thus, we got the coordinates of Q, that is alpha, beta. You can also test yourself. You can also test yourself delta for these values of alpha and beta. Delta 1 is equal to 0 and delta 2 is equal to 0. Thus, these conditions are satisfied. Therefore, the system has infinitely many solutions. So, thus, the coordinates of Q are 8, 6. 8, 6. We already have seen in the first slide the coordinates of P as 1, minus 2 and PQ square. Now, the distance formula, you take it, that is PQ square is x2 minus x1 square plus y2 minus y1 square, and simplify, you will get 113. So the answer to this question is 113, and I am sure that you have understood the solution of this problem. And we move to the next question. Question number 4. This question has appeared in the JEE Main Examination held on 31st January 2024 in the second shift. The given question is, let A be a 3 by 3 matrix and the determinant of A is 2. If n is the determinant of adjoint of etc. adjoint of A, this etc. is 2024 times, then the remainder of n when it is divided by 9 is equal to. The remainder when n is divided by 9 is. So A is given to be a 3 by 3 matrix and its determinant given to be 2. And n is given to be like this, determinant of, adjoint of, etc. adjoint of A 2024 times. Then required to find the remainder when n is divided by 9. It's an interesting question. Let's now discuss the solution of the problem in detail. Given A is a matrix of order 3, that means n is equal to 3. And the determinant of A is given to be 2, then let's recall a result from the section Matrices and Determinants related to the adjoints. If A is a non-singular matrix of order n, then the determinant of, adjoint of, etc., adjoint of A m times is equal to determinant of A to the power of n minus 1 to the power of m. Agreed? Let's get into our question now. Now, the determinant of, adjoint of, etc., adjoint of A m times is equal to determinant of A to the power of n minus 1 to the power of m. In our case, determinant of A is 2. In our case, n is 3. So that will be 2 power 3 minus 1 to the power of m. That is 2 power m. Agreed. Given n is equal to determinant of this, that is what we have, and that is equal to 2000 2 power to the 2 to the power of 2 to the power of 2024. M is given to be 2024. So this n you take this big number and divide by 9 and find out what is the remainder. That we do it in the next slide. Agreed. So that's what we have. Now we take 2 power 2024, write it as 2 square multiplied by 2 power 2022. 2 we have already taken, right? And why only 2? Because we wanted to write in the place of 2 8. How do I get 8 in the place of 2? The base. If I take 2 cube, that means 3 must divide 2022. Yes, it divides in such a manner and it is excess by 2. That is why we have taken out a 2 square outside. So 2 square into 2 power 2022. 2 square is 4 into 2 power. This is divisible by 3. That is 3 into 674. This 2 cube we have written it as 8. So this 8 we write it as 9 minus 1. So 4 into 9 minus 1 to the power of 674. Let's have the expansion, binomial expansion. 9 minus 1 to the power of 674 is equal to sigma r is equal to 0 to 674 of 674 CR into 9 to the power of 674 minus r into minus 1 to the power of r. So write this as, take out the last term. That means the first one will be sum r is equal to 0 to 673 and the last term is minus 1 to the power of 674 because r is equal to 673. If you 674, it's not 673, it's 674. Yeah, here it is 674 and this is last term and this is up to 673. Right. So the last term we have written last and it is r is equal to 0 to 673. Right. And now if you take r is equal to 0, it is 9 to the power of 674 only. And when you take the last term 673, it will be 9 to the power of 674 minus 673, it is 9. That means every term in this sigma notation is a multiple of 9. And the last term is minus 1 to the power of 674, which is positive plus 1. So it's a multiple of 9. So we will write 9 times of m. Multiple of 9 plus 1. Plus 1 you will get it because this is even. So we write here to 4 into this one is 9m plus 1. Then we write it as 9 times of capital M plus 4. 4 into 1, 4. And what is capital M? Capital M is 4 times small m. So what is capital M? 4 times small m. So therefore capital M is even. So 9 capital M plus 4 where m is even. And now take n is equal to 2 power 2024 is equal to 2 power 9m plus 4 is equal to 2 power 4 into 2 power 9m is written as 2 power 3m. Right. So again for 2 cube we will write 8 and that 8 is written as 9 minus 1. So 2 power 4 is 16 into 9 minus 1 to the power of 3m. We have already seen here. And when you multiply, when you expand by means of binomial, you will get 9 times a multiple of 9 plus or minus 1. It all depends upon what the 3m is. Here 3m, m is even, therefore 3m is even. Therefore, it's minus 1 to the power of even is plus 1 only. So you will get 16 into 9p plus 1. This is same as this one only. So right. Instead of 674, we have 3m where m is even. So you get this one. So when you multiply, it is 16 into 9p is 9 times q. 9 times q means q is 16p. Plus 16 into 1 is 16. So from this 16 we have written 9 plus 7. Then 9q plus 9 plus 7. That is 9 into q plus 1 plus 7. Right. Therefore, now divide by 9. When you divide by 9, the remainder is 7. The remainder when n is divided by 9 is 7. So the answer to this question is 7. And that is the detailed discussion of the solution of this problem. And it is definitely an interesting question. I am sure that you have understood the solution of this problem. We move on to the fifth question, and it is the last question in these numeric value questions. Right. And this question has appeared in the JEE main examination held on 1st February 2024 in the second shift. Now the given question is, let A is equal to I2, that is a 2 by 2 identity matrix, minus 2 capital M transpose, where capital M is the real matrix of order 2 by 1. That means it is a column matrix. So such that the relation M transpose M is I1. I1 means the 1 by 1 identity matrix. It is only one only, holds. Right. If lambda is a real number such that the relation Ax is equal to lambda x holds for some non-zero matrix capital X of order 2 by 1, then the sum of the squares of all possible values of lambda is equal to. Right. We are given A is equal to I2 minus 2 capital M transpose, where capital M is a real 2 by 1 matrix such that M transpose M is I1. And lambda is a real number such that the relation Ax is equal to lambda x holds for some non-zero matrix X, non-zero column matrix X. Right. And required to find the sum of the squares of all possible values of lambda. And again here, I am not considering the knowledge of a student regarding the eigenvalues and the properties of eigenvalues. I am not considering. Without that, I wanted to do that, because many teachers do not teach this because it is not included in the syllabus. That's it. But somehow some corporate colleges may be teaching this one. It's a different story. Right. So we will now move to the solution of this problem. Right. We are given M is a real matrix of order 2 by 1 and M transpose M is I1. So let M is a 2 by 1 matrix, means the column matrix AB. Then M transpose M is equal to I1. M transpose means the column matrix transpose is the row matrix AB multiplied by the column matrix AB. I1 is 1 by 1 identity matrix, that is consisting of 1 only. Multiply. It is 1 by 2 multiplied by 2 by 1 is 1 by 1. And it is A square plus B square is equal to 1. That's the first relation, let us say. And we are given A is equal to I2, that is the identity matrix, minus 2M, that is AB, into M transpose AB. Right. It is what? It is 2 by 1 multiplied by 1 by 2. It should be 2 by 2 matrix. So that will be 1 0 0 1 minus 2 into, when you multiply, it is the 2 by 2 matrix A square AB B square. So subtract. So we will get the 2 by 2 matrix 1 minus 2A square minus 2AB minus 2AB 1 minus 2B square. This is A. That's A. And we are given lambda is a real number such that Ax is equal to lambda x holds for some non-zero column vector x. X is a non-zero column vector. Remember that. So this will be Ax is equal to lambda x can be written as A minus lambda I multiplied by x is equal to the column matrix 0. Agreed. Suppose if I know, suppose A minus lambda I is non-singular, then its inverse exists. Multiply both sides by the inverse, then you will get x is equal to the 0 column vector, which is a contradiction because x is given to be a non-zero column vector x. Therefore, A minus lambda I must be singular. That means the determinant of A minus lambda I must be equal to 0. So if A minus lambda I is non-singular, then you will get x is equal to the 0 column vector, which is a contradiction because x is a non-zero column vector. Therefore, A minus lambda is non-singular is not true. Therefore, it should be singular. So, A minus lambda is singular. The meaning of that is the determinant of A minus lambda is 0. That is the determinant of the matrix A we have written, and that is equal to 0. We continue in the next slide. Right, we have this. We have this, and A square plus B square is equal to 1 also we have. So keep that in mind. Now take the determinant. The determinant is AD minus BC. That is 1 minus 2A square minus lambda multiplied by 1 minus 2B square minus lambda minus 4A square B square is equal to 0. Now multiply, and so this is after multiplication. So this is lambda square minus 1 plus 1 2 minus 2 into A square plus B square multiplied by lambda plus 1 minus 2A square into 1 minus 2B square we have written here, and minus 4A square B square we have written here. This cancels, right? 4A square B square, 4A square B square cancels. A square plus B square is 1. So this will be 1 minus 2. That will be minus 1 only. And here also in the coefficient of lambda, A square plus B square is 1. 2 times 1 is 2. 2 minus 2 is 0. So that means the coefficient of lambda is 0. When you simplify, you will get lambda square minus 1 is equal to 0, because we have used A square plus B square is equal to 1. Now the lambda values are lambda is equal to plus or minus 1. So what is that we want? We want then sum of the squares of all possible values of lambda is equal to. So then the sum of the squares of all possible values of lambda are, first value is 1 square plus second value is minus 1 square, that is equal to 2. So the sum of the squares of all possible values of such lambda is given to is computed to be 2. The answer to this question is 2. That is the detailed discussion of this question. And we have now come to the end of the discussion of 5 numeric value questions from the section Matrices and Determinants that have appeared in the JEE Main January 2024 session. I am sure that you have understood the solution of these problems, all these 5 problems, and I wish you all the best. Thank you.